0, 1, 1 0, 1 1, 1 0 0, 1 0 1. I have just counted to 5 in binary. Now, I'm sure you've heard of binary in some movie or TV show or something, but it is effectively a number system with only zeros and ones, hence the bi in binary. Another way to refer to it is base 2, because again, you have only 2 ways to represent a number and have to count using them. For instance, you grew up learning base 10, which is 0 through 9, then repeating 1 0 to 1 9, etc. Base 2 works the same way but takes way longer to count. So you have 0 and 1, simple. But just like how after you hit 9 in base 10, you need to move left and use 2 digits to represent the next number, binary is the same. So 2 in base 10 would be 1 0 in binary because we hit our cap for a single space and need to move left to fit more stuff to represent it. And it continuously increases just like this. So just like 99 becomes 100, becomes 101, then 102, and eventually 110, binary also follows that pattern. So after 101, we do 110, 111, 1000, and so on and so forth to infinity. But now the pattern should be a little bit easier to see. And now we're going to talk about why any of this matters. Remember how I said computers have bad memories? Well, this is another place this is true. Being able to understand multiple different states is difficult, but remembering two is a lot easier. Like a light switch, it's either on or off. A computer knows whether something is true or false. So while you and I work in base 10, computers work in base 2. Everything boils down in a computer to true or false. And by adding up a series of these true and false, everything else can be done. It's actually kind of crazy. True and false can be read as a number using base 2 math, which can then be converted to a character when the number matches an ASCII character. Put a bunch of characters together and you have words. So you go all the way from true-false to paragraphs. And one specific instance of a true or false is called a bit. And 8 bits make a byte. And internet companies love to imply that you're getting megabyte internet, but really you're getting megabit internet. 1/8 of what they implied you're getting. Just another reason Comcast and company are evil. But at least you know enough now to know what they're saying is BS. Also, if you are older, like me, you might remember 32-bit operating systems, even though they're all 64-bit now. The 32 and 64 represent the number of bits that can be used in a single block of thing. To give you an example of what that means, in a 32-bit OS, the biggest number you could possibly represent in a single piece of memory is 4,294,967,296. In a 64-bit operating system, that number becomes 18,446,744,703,709,551,666. Holy f***, that is a lot more. Another way to think about it is if we're using RAM in a computer. Our 32-bit OS can use 4 gigabytes of RAM, which can't even run Crysis, and our 64-bit OS can use 18 exabytes of RAM, which I'm pretty sure can run Crysis, but I'd have to check. To get an idea of how this works to convert the largest bit to the largest number, just do 2 raised to the power of the number of bits. I plan to do another video on binary math a little bit later on, and also plan to talk about another important computer representation, hexadecimal, or hex for short. But why do we care about bits and bytes and all that stuff? Well, remember your primitives? They each use different amounts of memory. Based on the first half of the video, you can guess how many bits a Boolean uses. 1. What about our ASCII characters? Well, original ASCII was 7 bits and thus only 128 total values. But remember how I said it was 256 in a previous video? Well, eventually ASCII upgraded to 8-bit to include a couple more different things. Okay, what about a character as a type? Well, Java was made after the realization of other alphabets, so a Java character is 16 bits. So it can include things like the Russian alphabet, hiragana, kanji, Chinese characters, etc. You might see something called UTF-8 or UTF-16. These mean Unicode, which replaced ASCII as a better way to handle all characters and emojis and everything else that can be typed into a text message. So what about int and double? An int is a 32-bit number, and a double is 64 bits. So remember how I said that numbers have upper and lower limits? It's based on these amounts of bits that they use. Don't worry about memorizing what they are. Your IDE will complain when you type an invalid number, and the exact number is given to you by Java. Now, I hear you say, well, what about those float and short things you kind of mentioned before? And to that, I say, damn, your memory is way better than a computer's. Exactly. There are other versions of int and double that use a different number of bits. So if you're trying to be super efficient or come across a really big number, you would use a different version. Bytes are super small integers. You can guess, based on what they said earlier, they are equal to 8 bits, i.e. have a max value of 255. Shorts are 16-bit integers, longs are 64-bit, and floats are like doubles except only 32 bits. And so far, when describing max values, I've been talking about using all the available bits. But what about negative numbers? Well, that's where things get complicated again. So let's use byte because it's 8 bits and way easier to understand. Really, of these 8 bits, you only actually get to use 7 of them to determine what your number is. The leftmost bit is reserved for saying positive or negative. So the biggest number is actually 127, which would be 2 to the 7th minus 1. And the smallest is negative 128. Similarly, floats and doubles don't get their full bits either. Some bits are reserved for positive negative, some are used to determine what part of it is the integer, what part is the decimal value, etc. And that's where Java kind of throws up its hand and says that's all you get for primitives. Every language has some shared and some different primitives, but they usually have these primitives under one label or another. Some languages have 128-bit numbers, and some languages support something called unsigned numbers. Like the name implies, there is a way to ignore the positive-negative place and use the whole thing as a positive number. So an unsigned byte would be 0 to 255 instead of negative 128 to 127. That was a lot of information for one day, so I'm going to stop it here. You should now have a pretty decent understanding of kind of bits, bytes, and how different values take up different amounts of memory for your programming language. I'll probably delve into these a little bit more into the future, but if you want me to talk about it sooner, just let me know below. Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.